All right, well, thanks guys for showing up today. I know everybody has other places they can be today, so thank you for giving us your time. Like Paul said, I'm Tyler Johnson. Our LLC is Northwest Kansas Soil Amendment. We started officially last year in 2024, but this has been a passion of ours since 22. Just kind of came about. We were both looking for ways to reduce input costs and try to move away from synthetic inputs, and found compost extract, and really haven't looked back since we started. It's been nothing but good for us, and so we wanted to share what we've learned with everybody else and help other people reap the rewards that we've been seeing. So what is compost extract? It is a liquid solution made from mature quality compost and water. Those are mixed together for 10 minutes in our extractor. It's agitated and aerated. And what that does is it takes the microbiology out of the compost and puts it in the water. It extracts also the soluble nutrients out of it, and then some of the carbon that comes with it. Kind of looks like chocolate milk, a runny chocolate milk after you're done extracting it. We run it through a 50 mesh filter and then a 30 mesh filter and put it on a nurse trailer. That'll last for about a week if you can keep it out of the sun as much as possible. You'll know it goes off when it starts to smell skunky. Kind of like skunky beer, and then it's time for a change, otherwise you'll start plugging filters and stuff. But why use compost extract? So there are three main reasons I'm going to talk about today. The first one I'll talk about in depth here on the next several slides, which is enhanced nutrient availability. That's where you're going to see your major return on investment right up front. Other things we're going to see long term is improved soil structure. The way that works is we're going to introduce beneficial microbiology to your ground. That's bacteria, fungi, nematodes, protozoa, everything our soils lack from years of salt fertilizer, years of chemicals applied, tillage, all those things decrease that microbiology population in your soil, especially the fungal population. That is a very slow recovering system. It's very fragile, so every time we go out and disturb our soil, it sets that fungal population back. But if we can manage to reduce those disturbances, it doesn't have to be all out. Any kind of reduction is going to help that stay stabilized and improve. And as we let that fungal population come back, it's going to start bringing in those protozoas and nematodes that are going to go out and eat all the bacteria in your ground, which is where a lot of your nutrients is tied up, is in dead bacteria in the ground. As well as all the synthetics we're putting in that get tied up also. But as we increase that biology in your soil, it's going to start exuding exudates from the fungi that are called glomalin, and that's going to start holding your soils together. It's a glue-like substance, and it's going to start on a really small scale. First, we call them microaggregates, and as those grow, that provides a home for even more biology. Those microaggregates turn into macroaggregates. And that's what's going to hold your soil together so that we can have really high populations of microbiology in our ground. And then as those die off and reproduce, preferably in the other order, then we're going to increase our organic matter. Because recent studies have shown that the increasing organic matter in your soil actually happens from the dead biology in your ground rather than leaf litter coming into the ground from the top, being pulled down with earthworms and things like that. And so as we increase organic matter, we're going to increase our water holding capacity, and you're just going to see that stack returns on top of returns where we're going to be more drought tolerant, we're going to be more efficient with our nutrients we have in the soil, and we're going to just have a more healthy plant all year long. And the last thing I want to touch on real quick is disease suppression. Anytime we go out and disturb our ground, whether that's with, like I said, the salt fertilizers, with chemicals, we're killing off those beneficial microbes that are in our ground and on our plant, so then it makes our plants really susceptible to disease coming in on the air, just things that are in the soil. If there's no competition for those bad diseases out there, they're going to infect your leaves, they're going to reach quorum, and that's when you're going to start losing your yield. So if we have something out there ahead of time that has already inoculated those leaves, inoculated your roots, when something detrimental comes in, it can't get to that level where you're going to start robbing yield from your crops. But the main thing I want to talk about today, like I said, is nutrient availability. So how do we achieve that with compost extract? So the first and easy thing is the microbes we put out there are going to help break down that organic matter in your soil and make that a more plant available form. That's the easy one. The one that makes the real difference though is that where it forms that symbiotic relationship with your plant roots. So if you don't have a synthetic fertilizer sitting right there, like in the form of 1034O in your seed trench, and instead you put beneficial biology out there, that plant root is going to see that biology and it's going to form a relationship with it. That plant is going to exude carbon into the soil. It's a sugary substance. The microbes are going to eat it and it's going to want more of it, so it's going to look to the plant to signal what it needs, whether that's phosphorus or nitrogen or micronutrients. It's going to go out and get it and bring it back because it wants more of that sugar so that it can reproduce and continue out its life cycle. Like I said, phosphorus fertilizer is the easiest one to replace up front. Listened to a webinar the other day from Dr. Christine Jones out of New Zealand, and she's spent her whole life studying microbiology and synthetic fertilizers, and she says that your plant is only able to use 10 to 15% of the phosphorus fertilizer that you're applying every year, and that 80 to 90% of that, not only is it immobile, but it immediately gets tied up with the calcium we have in our soils out here where we've got a pH 7 and above. It happens below 7.2, but it's a different process with a different nutrient. And so one, you're putting that phosphorus out 1 to 2 inches below the ground in the seed trench, and once your plant grows past that, it's no longer going to be able to use that phosphorus. It doesn't have the symbiotic relationship, so it is only going to be able to access the nutrients that are just immediately around that root. And so instead of being able to grow in your whole field, you're basically growing in a flower pot. And so if we have that biology there at planting, whether it's on the seed, in the seed trench, then as that root comes out, it forms that relationship with your plant, the biology does, and then that biology can reach out 15 inches all the way to the center of your row. It can go down 15 inches. That fungal hyphae has been shown to go, they don't even know how far out it goes, but it's an extremely long ways, and it's also a lot finer than any of your plant roots. So it can get into those micropores, access nutrients in them, access water that it normally couldn't get to. So you're going to be a more healthy, more drought resilient plant at that point. Here are some of the results we've seen on our own fields. There you can see my daughter's holding up this plant that we saw in 2023. It's the first year we applied it. The compost extract in furrow, we were running about 5 gallons an acre there. And that field, we did absolutely everything horrible I could think to do that field. Not because I was trying to, it's just what happened. We went out and had corn failed on it. We hayed it off. We came back and tilled it. We then went in with wheat, and about the only good thing we did for that was we left stripper straw out there. So first year no-till field with corn, no 1034O. We still ran 32 alongside with other products from Nutrient at the time. But in furrow, all we ran was compost extract. And that's the kind of root mass we saw that first year. And the thing I really like to point out is this root that ends all the way down here. That went down 12 to 14 inches right through our plow pan and was able to pull water up from farther down. We saw that field stay green longer in the season than all of our neighbors. In the end of 2023, I believe we went 45 days without rain on that field. We managed to yield 75 bushels the acre there. And I mean, you can just see how much more root mass you got. That's all she can do to hold that thing up. And it just goes to show how much more nutrients you're being able to pull in. And you can see there's roots coming way off over here to the side. This is the reason I got her out there, was to look for earthworms, because she was still at a stage where she thought earthworms were cool, and I love them because they're my passion. But that's the first earthworm I found in my growing season ever, right there. But you can just see how long these roots are. Every one of these went right through that plow pan. It's going to help your water infiltration from every year on past that you don't disturb that ground. This is the very first trial we ran here with some oats in the spring of 2023. We did a trial where we left about 10 acres untreated, so that oat cover crop didn't get any extract over here. And they're not exactly white bare roots like you would see if you went out and looked at your field where you were applying 1034O or something like that, because it had to go find its own nutrients. It did use the biology that was already in the soil, but you can see the difference here between the two. This was where we applied 5 gallons to the acre, and it's about twice the size of it, and about 75% of the plants we went out and pulled up, that was the response we saw there, and this was the biggest root mass we could find in the untreated area. So this is kind of our setup. We've got set up over kind of in between here and in Levant. We've got it set up in a round top. This is our extractor here. This is where we put our compost and our water. These are our freshwater tanks. Over here we can hold 4,500 gallons right now at a time. And generally, you know, right now the most we can make in one batch is 1,000 gallons. It takes us 45 minutes, which is long enough for us to refill that 1,000 gallons and the time it takes us to make the next batch. So I think we can make up to like 8 or 9 batches a day if we were really pushing. Like I said, 1,000 gallons every 45 minutes. Fresh water and compost. 1 pound of compost makes 4 gallons of extract if we're putting it in furrow or through a foliar system. When we make our seed treat extract, we run 1 pound per 1 gallon, so that it's a highly concentrated extract so that we get as much biology on that seed as possible. It's really safe for your equipment. There's no salt in it. It's not going to rust out your bearings. If you have a blown hose or something and you spray it all over yourself, there's really no concern about it. I wouldn't go out and drink it, but you know, it's not going to hurt you if it stays on your skin all day. You don't have to worry about it being around your kids or anything like that. This is our new extractor we're going to have up on that stand. We got it right there now, and we're really excited to use this. It came with a batch computer. It shaved 20 minutes off per batch. That's how we can get out 45 or 1,000 gallons every 45 minutes. That's with cleanup and everything. This extractor has a lot more jets and recirculation on it. So our old one would leave a layer of sediment around the outside after it had been screened. And now we're able to get that up in suspension, and that's just more biology, more carbon, more nutrients that we're going to deliver to your seed trench or to your plant. This is kind of a look into our future, where we're going right now. We get our extract from a place out of our compost out of Hutchinson, but we're wanting to make that in Western Kansas with Western Kansas microbes, because I think that's the next progression for us, is just make it as local as possible for our growers. I think the more local your microbes can be, the better. So this one composter here is 8 foot long by 4 foot wide and 30 inches deep. It produces 160 pounds of vermicompost, which is worm compost, a week. Our goal for 2026 is to have 4 of those going, producing 640 pounds of compost a week, 54 weeks a year. I think I did my math right there. But that's made out of straw, oat hay, hemp hurd, which is just the woody part of the hemp plant, because we have a hard time getting a hold of hardwood wood chips out here, and dairy manure. And so I'm going to kind of cover how we apply this product, and I've told you how great it is. This is my favorite way to apply it, is in furrow with my planter or with my drills. We apply 5 to 8 gallons per acre. We run 30 to 50 mesh filters on all of our equipment. That's in the nurse trailer, on the planter, obviously in the extractor. I use metering tubes, and I don't have any kind of problems with that plug-in whatsoever. In fact, this last year I wanted to see just how far I could go before I had a problem. I ran 800 acres before I finally plugged the metering tube and had to replace it. I didn't clean my filter. I didn't do anything. I treated it as poorly as I could. And so that was a major benefit for me, because if you're not worrying about plugging up all the time, it's just one less thing to worry about at planting. I think the benefits here is that you're getting a lot of biology in the seed trench, in between the seeds, and I think this is probably the best option, place to start, if you are set up to run liquid. So cover on that. We do have a couple of nurse trailers available if you don't have your own. We can kind of help you out there. And we're hoping to add more as we get more and more customers. And we kind of see the same pop with this as we do a traditional starter fertilizer. I've kind of compared it about everywhere I can, and I don't see us lagging behind anywhere. You might, once it comes up, it may stay a little bit smaller for about a week, but if you go out and dig it up, you've got about 2 times as much root mass below ground as the guy next door does. So he might be an inch taller, because it's trying to get up and get more energy photosynthesis or through the photosynthesis than it is through the ground where we're growing roots and we're getting a lot of that initial energy from the ground instead of having to grow up above ground real quick. So if you aren't set up for liquid, one thing we're adding this year is a seed treatment. For corn, milo, and soybeans, we're looking at 2 to 4 ounces per pound of seed, and that's not enough liquid to make your seeds germinate or anything like that. It's just enough to get them damp, and by the time you get them back into a pro box or into a seed tender, you're not going to even know we did anything. It's going to be dry. But what that does is it just gets that biology into the seed coat on your seed, so that as soon as it puts its first little root out, it's already inoculated with biology, and then it can re-inoculate every root and branch and hair it puts out from there on. For wheat, we're looking at just under a half an ounce per pound of seed. Like I said, we're just trying to get a little bit of biology out there so that you can pull in more of those nutrients and form that symbiotic relationship. Also, like I said, we're working with EAE this year. They've got 2 products that I think are going to work really well with the seed treatment. One is Seed Flare, which is a micronutrient treatment. And then the other is BioTilt Gold, which is designed to kind of replace your talc or graphite in your planter. But what it has with it is a carbon source and fungal spores. So it's just another way to get even more biology in your soil to reestablish those populations so that your plant can thrive all year long for a cheaper or for a better bottom line. This is one thing I'm going to start doing this year on my farm. I've got a sprayer finally so that I can start running some of my own trials. We're going to do foliar fertilizer or foliar biology when our corn's about V3, V4, kind of the same thing for milo. Our foliar will run with all other foliar nutrients. We're only looking like 2 to 3 gallons per acre. That way we just want to get it out there to recolonize the leaf surface and to prevent airborne diseases there. Like Roundup originally was designed, I think the first patent on it was an antibiotic. So when you're going out there and you're spraying your corn, it's killing off all the biology on your plant leaf surface. And so if you can, as soon as that goes through and we clean up our weeds, because that's a great product, I don't want to take that away from you, but if you can make another quick pass over the top with some biology to re-inoculate those leaves, then every time it puts out a new one, as it comes up through that sheet, it's getting more biology put on it, and every leaf after that will have that biology there. And then, another place we could probably get it out there, I think would be beneficial long-term, is post-harvest. Just go out there and drench over the top of all your residue to get that to break down a little bit faster, to release more nutrients back into the ground, and just let those populations work all winter long. This is something we designed last year, and we're really happy with the results where we saw it. We're hoping to get enough time to run it out on a lot of different applications this year. It's a little 14-foot aerator. Don't pull it behind your pickup if you're just working on it. It would work to get it out of the tree route. But we've got 2 IBC totes set up on there, and then right now it's just set up to run gravity flow down to a PVC pipe, and we're just running a little stream out per tooth on the aerator. This is where I think this is going to make a lot of impact, is somewhere like in your pasture or established alfalfa stands or end rows on your fields where we're running the semis and the grain cart and everything we've got really compacted. If we can get that biology down into the ground near those already established roots, it's just going to help them be that much more productive. We think it'll help with spring green up in our pastures. That's where I think this is going to be the most productive. I think, an alfalfa field, it'll do really well. Like I said, I'm going to run it on my end rows. I've got one field that is just perpetually bare for 80 feet at the end of the field. So I'm going to run this with about 8 gallons an acre along those end rows, probably 2-3 weeks before I go out and plant, and then come back and run it in furrow again with a seed to try to get some of that compaction alleviated. There's a lady in Australia by the name of Nicole Masters. She loves this in horse pastures where it's been really compacted, overgrazed, and it's just getting that little bit of biology back in the soil, tickling the system back alive. You're not trying to apply all the biology forever in one pasture, just trying to get enough out there to start a colony so it can start supporting itself So local results, I've talked about my farm quite a bit. Like I said, we started in 2023. We went all in. I jumped off a cliff and just cut out all my 1034-0 in 1 year. It was terrifying, but it worked out amazing for us. We haven't seen any yield drag, and I haven't looked back once. We had about 7 local producers start running this in 2024. We've had it out on corn, milo, millet, feed, cover crops, summer cover crops, which I don't have up there, alfalfa. We put it on our trees quite a bit and see a pretty big response to that. And that just came about because I screwed up and overflowed one of my tanks. And so I said, well, what am I going to do with all this extra product that I have? I can't take this down the road, it's just going to spill out. So I took it over and started dumping it on my mom's trees. Of course, I didn't tell her about it. So she calls me up a week later, she goes, have you noticed how great my trees look? And I'm like, yeah, that was me. She goes, well, why didn't you tell me? I said, in case they died. So then I got a short video here. This is a producer over by Edson. He put it out with that aerator after he plowed up the alfalfa stand that was there. So this is just 9 gallons of our extract with that aerator and the residual nitrogen from that alfalfa. But you can see, for reference, there's a swather coming through. If anybody wants the engine noises, I can turn the TV volume back up. But you can kind of see the amount of biomass he's getting there off of it. And we won't talk about the skippy leaves here. But yeah, he was just tickled pink with it. So here's a still photo of it, and you can kind of see back here, there's the center pivot hiding back in there behind his feet. Here are the kind of the stats on it. From what I recall, we got 91 bales, 1,250 pounds a bale off of 15 acres. Like I said, ran 9 gallons an acre with the aerator and just the residual from that alfalfa stand. Last thing I'm going to talk about just real quick is if you want to, we can add a food source for that biology. That kind of helps in that scenario where your seed might sit out there for a while before it germinates. One thing, in the past 2 years, I've been running these 2 products over here with a lot of success. One, the blackstrap molasses, is a short-term food supply. It's just a sugar for your microbes to eat until that plant comes out and puts out its root, and they can start exchanging carbon. And you get some trace minerals in that molasses also. I ran fulvic extract also last year, which it is also a long-chain carbon for those microbes to eat, but also it's going to help you with your nutrient availability in that seed trench. I'm probably replacing that fulvic this year with Humicarb from AEA, which gets you humic acid, fulvic acid, and humin. Oh, I think I'm saying that right. All in one package. And I'm not saying go out there and run 2 or 3 gallons of any of these. We're just talking ounces, just enough to keep that biology going, to get a really good population established in that seed trench for your plants to thrive on all year long. And Jeff is going to talk here after we eat about more of the products that AEA has, and we're going to be dealing with them here. So anything you want to try from them, you can contact us about. Here's our contact information for anybody who didn't grab our numbers. There's our email address, any questions you might have. And this is my favorite picture, next to my family and my daughters. This is the first earthworm I found on our farm in the field. You know, I remember being out there running sweeps and everything, always looking for earthworms and never being able to find any, and just kind of feeling like our soil was dead. After we've been applying these, we see so much life in the soil, lots of earthworms. The soil smells a lot better. It smells like you open a bag of Miracle-Gro, that real earthy smell. Now, I just don't think there's a place on this planet that compost extract doesn't fit. So, one last thing to talk about, and then we'll get to eating some food and questions. With AEA this year, we're going to be out taking sap analysis tests for anybody who wants to run them in season. Jeff can kind of go into the details exactly on that, but Paul and I will come out and take samples for you, send them off to the lab. They'll get run through the experts at AEA. They'll send them back to us, and we can sit down and talk with you about any kind of in-season nutrient needs you might have. If it looks like we've got a scenario where we can maybe capture a little more yield. I'm really excited to see what those tests show us this year as we start to take them. So I guess I'll open it up for any questions. Anybody has them?
Yes.
Yeah.
So you said you like putting them on with So you're putting on how many pounds?
I put down 5 gallons a
5
acre,
gallons.
which equates to like 1.25 pounds.
So if a person was, putting it on the strip till, how much would you put on the strip till?
So in irrigated, we kind of recommend 8 gallons the acre, you know, somewhere in that 5 to 8, whatever works for the tank size you
Is
have.
that mixed with?
So I would-
just?
I would try to put it out by itself, if you could put it, you know, as a replacement for your 1034L. And I put the strip till on there for if you're not set up for liquid on your planter, you could put it out there ahead of time with a food source, and then come back in and put your seed right back into that same slot, and that biology would still be there. And I put on their spring strip till. I don't think if you put it out in the fall, you would see as many results as if you were doing a spring pass. I don't have any irrigated, so I can't tell you exactly how that would work, but you know, in theory, I think that would work pretty well if you weren't set up to run it in furrow with your planter or your drills.
Okay.
Any other questions? No, we can get some food. Yeah.
Quick one. I understand you're super early in all this.
Mhm.
Have you done any like hanging tests or anything?
Yes, sir, absolutely. I highly recommend a hanging test with any of this. That's one way we've been able to cut back a lot of our nutrients with confidence. So I pulled that hanging test the first year. It showed me I had 30 pounds of phosphorus in my soil that was either immediately available or would become available in season. And also it's how I've been able to pull my nitrogen back 20 to 30 pounds in my corn per acre or 10 pounds in my wheat, because it showed I had between 30 to 50 pounds of nitrogen available throughout the season, either inorganic or organic forms.
And then have you seen it?
So
Yeah,
I pulled my first ones last year.
Okay. So
I missed the window, pulled them in the fall, so as soon as it warms up,
Yeah.
I'm gonna go out and take some this spring and see how that transitions. You know, I've had a lot of crops burn up, so I'm hoping I can continue to see that go up, you know, right? But, yeah, no, I think that's a great thing to do hand in hand with this, because one, it's gonna tell you your soil respiration rates, and that's just, they put it in a test that shows how much CO2 your soil produces in a 24-hour time frame, and the more it produces, the more biologically active your soil is. So that's something you can kind of track year over year to see if you're moving in the right direction to have a more microbial active soil. It's that CO2 test. Other than that, we can kind of start working through the food line unless anybody has anything else right this second.